Good evening, everyone. Good afternoon. My name is Marcin Koscinski, and I'm a member of WIRE Foundation. Today, we have a pleasure to host Christopher Maronga, an R user from Nairobi R user group, Kenya. Christopher will present some innovative open source approaches to automating research data management. Basically, he will present how to integrate Rshiny and REDCap. Christopher was a host in November at our webinar, so it is my pleasure to see him on the second side of the seat with a microphone as a speaker today. Christopher has a background in mathematics and is currently finishing his master's degrees in statistical science at Strathmore University. He's a data manager at KEMRI-Wellcome Trust Research Programme and a co-organizer of Nairobi R user group. He's interested in predictive modeling and joint modeling of longitudinal and time-to-event data. We're happy to have you here, Christopher. We always invite a broad spectrum of speakers from various backgrounds and from various places around the world. And if anybody would like to give a talk, just let us know on the channel. And if you have any topic that you find interesting and would like to speak at our webinar, just let us know. And for now, Chris, the floor is yours. Let's get all the questions and comments on the chat, and then we will have the Q&A session at the end.
Okay, so thank you, Marcin, for the kind introduction. So I'm just going to share my screen. Okay, so as we heard, so my name is Christopher Maronga, and yeah, I'm a co-organizer at Nairobi R user group in Kenya. So these are community work that we are doing with some colleagues of mine, Shelmith Kariuki. I know she's a very familiar name, and Kigen Tembu. So it's basically a group where we hold meetups on a monthly basis, regular basis, so that we can try to build skills for guys interested in data science and R programming. Okay, so today it's my pleasure to talk to you guys. I'm just going to present something on how you can use open source technologies to automate research data management. That's just an overview of what I'm just going to go through, and probably at the end of the session we might have like questions that might elicit a little bit more of the expansion of the topic today. Okay, so we all know that for all health research, that is, we are talking about the clinical trials and epidemiological observational studies, the prospective studies. So all those health research involve the collection and managing and processing of study data. So, and the major aim of this particular process in research, that is data management, is basically to output a clean, reliable data that can help you make trusted conclusion after you've done your research. And this particular component of research, that is the data management, is usually very costly, especially when it comes to low and middle income countries, because setting up, getting the resources, setting up the systems might quite be strenuous, and therefore this becomes a challenge. And you realize that now research is being done in such the low and middle income countries. They struggle a little bit when it comes to this particular component of research. So we all agree that a good data management is quite important and beneficial for any success of the study. In fact, a research study is as good as the data management workflow that it has, and therefore potential issues with research data management needs to be addressed in good time whenever you plan for research, and therefore that's what I'm going to talk to you about today. So some of the potential data management issues that I've come across, these are the most common ones. I know there are a wide range of issues when it comes to data management in research. So we have the issue of having data being stored in different locations. That is, you have data, you've collected data, but your repositories or other databases are located elsewhere. You're not having a central like repository for your data. So therefore, whenever you plan for a data management workflow, you think of how you will pull those data sets from different locations. So you merge them so that you can be able to have a coherent like cleaning process. And again, I know the research design. So we have the most basic research design, study designs, which you collect data at a single time point. That is the cross-sectional. But there are other study designs, the likes of the longitudinal, which you collect group data. So these complex study designs bring a challenge when it comes to planning for databases, because you don't have the full potential, or rather you don't have the full capacity to be able to implement some of the validation that you might want in your database. Again, when you have multiple individuals entering data into a database, that is you have, for example, several data entry clerks doing the data entry. Some of the errors that might come across due to transcription might be varying, and this also extends to studies which have different sites that conduct the same study. So now I will say that every other data manager or other a researcher who is interested in collecting good and clean data might appreciate the ability to be able to monitor in real time the quality checks, or rather the data quality progress of their study. So I think that's one thing that open source technologies can achieve. And I'm going to present a case of how that has been implemented to monitor real-time quality checks for data, and also author reports in real time. Okay, so what I'm going to present today is basically in the context of chain network. So chain in full is childhood acute illness and nutrition network. These are large observational study that was conducted in various countries, as you can see on the map there. And the coordination center was in Nairobi. That is where all the activities were being coordinated. That is data management and other administrative activities. So this was a cohort that enrolled children who were undernutritioned, and so we enrolled from across 6 countries with a total of 9 sites. So you can see the distribution, the geographical presence of the study in terms of the active sites, as well as the various coordination and the various exercises that were being done across different collaboration institutions. Okay, so having talked shortly about the chain network, so the main cohort of the chain network had about over 4,000 records. So this basically covered a wide range of variables, about over 1,500 variables. We also had some other, like we call them the sub-studies. So these are studies within the main study. So again, these are different cohort of children who are enrolled to assess basically the nutrition, and also this was a survival kind of study whereby we had children who are undernourished, and the main outcome was basically mortality. So again, so we collected various a wide variety of variables ranging from demographics, clinical features, socioeconomic, and the phenotyping that basically we wanted to try and phenotype the various risks of child mortality in this particular cohort of chain. So so we also collected a wide range of lab data. This was basically metadata. That is the maybe date and time samples collected, the patient test results. So this was a very huge kind of data for the lab with over 0.9 million records across more than 18 process variables. In terms of data velocity, we had we had 48-hour turnaround time. That is from the time the data is being collected until when the database is being updated. So we required a 48-hour turnaround time. So again, data was coming into our databases real quick. So you might go to sleep one night, waking up in the morning, you find your database is up by around 15 records, because again, as you saw in the geographical map, we had sites from different time zones, and yeah, that was happening. So the data velocity was quite high, and we foresaw challenges in terms of data management, and therefore we saw it fit to basically come up with a better way to manage that data in as opposed to the traditional way of doing it manually. Okay, so this slide is basically a proposed QC model. So QC for quality control. So for those who are in the data management or rather health research, you'll be familiar with this particular workflow whereby you have a level of QC. So one thing I want to mention about the chain network, what the direction it took, we had a paper-based data collection approach whereby data is being entered into a paper CRF. So then again, the paper CRF is being transcribed into a database central somewhere, and then the queries are being done electronically by extracting the data from whenever repository. Then you can run the validation scripts against the data set. So now, if you just going through this particular workflow, so we normally, depending on the manpower, like depending on how well your site is established, you might have several levels of queries or other QC levels here. But again, I think two of them are enough. So whereby the first one is a clinical staff who maybe does the initial collection of data. So they go through the paper CRF, checks for any inconsistency, any missingness, or any other thing that does not really coincide with the protocol and the laid out operating procedures. So then once that is done, the second clinical staff again does just go through over to just make sure that everything else is clean. And whenever anything that they find a mess, they could flag and actually notify the person who collected the data original, to maybe change, or if it's a wrong date or something that has not been really quite validated well. So then once this process is done, these are at site level. So at site level now, we believe that data is clean. Now it's being entered into the database. So again, our primary database for this particular study was REDCap. So up to this point, the site has done what they are able to do. They have cleaned the data. They have done the source document verification. So at this point now, this is where we come in as the central data team. So whereby now we have pre-written scripts for validating the data for cleaning. So we extract the data from REDCap. Then we run our pre-written instructions, just checking, double checking from the protocol what we defined for each variable. And initially, this particular step here, now you feed back to the sites in terms of now sending the sites queries. And again, this was kind of a manual process whereby you write an email to sites. If you come up with a query, your script picks up a query, you send them to sites. And remember, these are 9 sites. So if your N is large enough, you can imagine the number of emails you send back. So it's a back and forth. So it's manual, time consuming. So that's when we actually came up with the Rshiny framework, whereby now we eliminated the step of sending emails. So the only way we could feed back queries back to sites is via the use of Rshiny, which I'm going to now illustrate next. So now we eliminated this particular manual step, then replaced with a much efficient and automated step using the Rshiny in conjunction with REDCap. Okay, so in terms of implementation, so we basically focused on the risk-based approaches of data management. That is, we had a predefined list of variables, the variables that the principal investigator thought that are key in answering the study objectives. And we did a real-time check on those variables, both in terms of item missingness and basically the variable missingness in general. So with this, we are able to capture up to minute inconsistency and anomaly, in the sense that we are able to, so because it's automatic, it's automated, it's an automated process, we are able to capture an anomaly or an error as it happens. So whenever they enter, if it's a wrong date, if it's a wrong entry that exceeds some pre-specified rules, we are able to capture it like as it happens. So yeah, and you will want for a large cohort like this one with very many sites which are basically geographically dispersed, we'll want some standardized reports. So we are able to have like very standardized reports yet interactive. So these reports include the accrual curves, reports on loss to follow up, and just a check on missed visit summaries. And the other thing that the other useful things that with this standardization of reports, we also had various sites PIs requesting for customized utility reports. So some of these utility reports were for site-specific consumption, for planning of future tracking of follow-up visits and events as the study progresses. Okay, so these were our tools of trade. So our tools of trade, as I mentioned before, we used REDCap. REDCap is in full is research electronic data capture. And we also had another database, which was a relational database management system, which we called KEDIMS. This is locally developed. And the main ingredients for this particular workflow is the RStudio and Rshiny. So if you ever heard about them, so RStudio, basically R, and Rshiny is just the Rshiny package, which basically contains a framework of developing web pages using R. So this is just a tiny anatomy of how Rshiny, like the building blocks of Rshiny. I'm just going to demonstrate how you can use Rshiny to automate research data management workflow. I'm not going to go into depth on how you can code an app from the scratch. That one, I think you can find a lot of resources online, and you will enjoy the vast of materials out there. So so Rshiny is basically composed of a typical Rshiny application is basically composed of two files: the UI, which we call the user interface, and the server. So the UI is basically a set of nested R functions which give the HTML layout of the app, and basically that's where you get the controls, as we are going to basically lay out demonstrate later. So this is where now this basically, I will say, this is the face of your app. Whenever you create an app, whatever skin, whatever color, whatever arrangement of outputs you have in your dashboard, that is the work of the user interface, which I would say is just a set of nested R functions. The server is also is basically contains the instruction. This is where the real work happens. So this is where now you write, or if you are doing analysis, if you are doing maybe data cleaning, this is now where you write your specific instructions to do the specific task that you want, so that you can be able to output those on the user interface. So again, these are basically R, like a collection of R reactive functions, and they contain the specific task that the item the user wants to accomplish. So then there's the function called Rshiny App. There are so many there are various ways of doing this, but this is one of them. So this is just the ignition key, whereby now it combines the user interface, which is a set of nested R functions, and the server script to just give you a completely working Rshiny application or dashboard. Okay, so how does this work? How does the user interface, or rather UI.R or server.R work? So as I've mentioned, the user interface, which is a set of nested R functions, is basically produces what we call the input widgets. So these input widgets are what enables you to control whatever output you get from your dashboard. So whatever is in your UI section collects parameters. So these parameters are user defined. So maybe you want to select a site to view, maybe you want to select a range to basically, maybe a date range you want to view report for. So once these parameters have been collected, so then they are being like communicated back to the server, which I have said is also a set of R functions, which most of them are particularly reactive. Reactive in the sense that whatever, if anything changes in the data, the input data, the process executes all over again, and you get a new output. So in the server sections where you load your data, you can load your packages. So again here, so as I said, this is basically where you perform your specific task. So whatever, whether you want to create a table, you want to create a graph, you want to fit a model, any task that you want to accomplish using the Rshiny dashboard, the actual code is being written in the server. So once this is done, an object is rendered. So this rendered object is what now is being pasted as an output on the user interface, which is the basically I can say a web page like layout. Okay. So so this is actually how we put the pieces together. So I've talked about the central database, which is REDCap. So REDCap was basically our main storage of clinical data. We had another database which we used to store lab data, which was a relational database management system, which can be easily created using MySQL. So now, so as you can see, this red arrow simply indicates that we are extracting. So we are extracting data from REDCap automatically. So with we actually leverage the help of the APIs, the application programming interface. So one of the packages that we heavily use is REDCap API. So the REDCap API is one of the package that can assist you do a seamless extraction of data from REDCap from whichever platform of R, whether you are using RStudio Server, you're using RStudio Desktop, or you're using generally R. So we extract data. So the data is extracted from within RStudio Server. So this system was set up in a Linux server, just to mention. So then in RStudio Server, there are two things that happen here. So we have processing. So once the data has been extracted from the from REDCap into RStudio Server, it's being processed. So we have pre-written scripts that are residing in RStudio, which basically process the data that comes from REDCap or from the other relational database management system. So the processing involved basically creating your variables, just making your data ready for whatever task, either reporting or analysis. So one thing I want to mention is that inside RStudio Server, everything that happens here is task managed, in the sense that we have written task schedulers, whereby now the extraction process is basically it does not require human intervention to take place. So we've just automated it, scheduled it, so it takes place regularly on time interval that we have been given it. So once RStudio in the RStudio environment, data has been processed and everything has gone, or rather all the scripts have been executed as planned. So that processed data is now dumped into the Rshiny box. So Rshiny server is also within the same environment. So inside the Rshiny server, this is where we have the UI and the server scripts. So those are the scripts that contain the specific instruction to clean the data and conduct the or rather author the reports, or rather create summary figures and anything that you want. So, but mostly I will just focus on data cleaning. So whichever instruction or whichever validation that you are thinking of in your data set, so those particular instructions are contained within the script that lie within the Rshiny server. So, and again, I just want to repeat once more is that once extraction is done here, which is automated, processing is done here, which is also automated, that processed data, which has been finalized from within our RStudio server, is dumped into Rshiny server. Now, Rshiny server here is where we have the UI and the server scripts, which basically form the Rshiny application. So once that process runs, like the UI and the server through Rshiny Apps call executes, we post various outputs in form of a web page, which can be accessed from various sites within the network. So this is a process that is automated. So the extraction, processing, cleaning, and pasting is the process that we basically automated. So, and how we automated is we put a constraint in the RStudio server that initiates. So the constraint in the task scheduler is what invokes the process. So for us, we did about 20 minutes. So this process repeats itself after every 20 minutes from the time it was created until maybe something else goes on. So one thing maybe to also mention is that in the entire process of extraction, processing, cleaning, and posting, there's no human intervention. It's just an oversight. So just oversight and see that everything else is going on as planned. Scripts are running as expected. So for instance, if site N had seen a query regarding their site in the dashboard, so they'll go back to the database, make the correction. So once the correction has been made, so this process is continuous. So you make the correction, it is extracted, processed, again run through the various validation rules. Then that particular query will not be displayed here because now the site has corrected it, and now the particular item conforms with whatever rules that was set here in the cleaning script in the Rshiny server. Okay, so this is just a basic dashboard overview. This is a landing page. We basically had several dashboards doing different things for various studies. So we have the main cohort, we have the sub-studies, we have the laboratory data. So we basically run a multiple apps. So and most of all of them were like protected. So you can only access them if you have the credential to access them. So and every other site lead or other site personnel had the access. So yeah, that's just to clarify that it wasn't open for everyone to see. This was basically for the research that was being used for. So I'm just going to display a sample output from the system that I've just described above. So you can see these are basically a few reports, like bar plots for accrual numbers. And this is the widgets I was talking about, whereby you can select. So you can basically, this is not interactive. This is just an image. You can select a specific site to see the very report, but for that particular site, and as well as selecting date ranges for which you want to see the report. We also heavily use the app to basically run the queries. So this is just another sample dashboard output which contains the sample of queries that we did for each and every like data point or other data observation that was collected. So for instance, you can see this was a rule that was basically checking if two dates are conforming to what we expect. So if any data point violate this rule, it will be posted here, and sites will be able to view this, and they can pick this record ID, go to the database, and basically correct that particular query based on the comment that we've given them here, which is just a hint on what we need them to do. So once this is done, the process runs again, like the previous slide, then you get something like this down here. So now you don't have anything to post because every other data point has conformed to your validation rule that you had earlier set. Okay, so we really gained much in terms of setting up this particular workflow. So one of the things we did is that we are able to get a seamless data extraction and processing without any human intervention. So as the previous slide, so that process of extracting, processing, and extracting and processing was basically an independent, like it runs on its own after every other 20 minutes, and therefore you'll bear with me for those who have used REDCap before. If it's a longitudinal study, you need to basically extract different events or other different forms, and then extract, then combine so that you can have a complete or rather a full data set. So if that process is seamless and automated, I think that cuts down on the amount of times you'll be able to do that manually. We are able to run automated cleaning scripts inside the Rshiny app, and we are able to monitor real-time data checks. So these were happening like on a real time. So we are able to basically see what's going on with our data set. what kind of errors are being committed, and how what's the turnaround time of query resolution and management from the site perspective. So, and we also had the benefit of having standardized study reports, which were being consumed by various study PI and staff. And the monitoring of real-time study progress basically helped like track the likes of loss to follow-up or other potential missed visits that are bound to happen due to the fact that some patients might like not really turn up for their appointments. One of the major gain is the productivity of the data team. So this was improved a great deal, because now in the initial QC model, the site data managers were basically relying on us as the central data team so that we can be able to send them queries or other via email. But with this system, they can take charge of their data cleaning for their site, because everything else is posted on the dashboard. So they are able to really cut down, rather plan for when they are supposed to do what query resolution, and actually monitor their progress and the performance. I actually came across this slide, this picture in Twitter today, and it was a bit very relating to what I wanted to talk about. So yeah, it reads, I spend a lot of time on these tasks, so I should write a program to automate it. So yeah, basically in theory, that's what you will think, that whenever you have, so on the y-axis, the amount of work that you maybe are doing on a particular task, then on the x-axis, the time you spend. So basically you write codes, you try to redefine the original task. So then you think once you do an automation, then you'll have free time going forward. That's in theory. In reality, that's not the case, as you can see. And this is not trying to contradict what I'm saying about how automation is effective. I'm just trying to say that it's not really the solution to everything, but it is the mother of invention, because when you write that code, which automates whatever task you want, keep in mind you'll also be doing debugging, because it will keep on breaking down. And basically, you won't stop there. You'll be thinking of some development. So you'll be thinking on how you're going to use this particular data product further. And you see that's more work you're adding yourself. And at that point in time, you realize that now you don't have even time for the original task anymore. You have time for just developing that app, debugging stuff. And yeah, so it's a nice implementation. And yeah, it helps basically save on time on repetitive tasks such as data management. So we faced a few challenges in implementing this workflow. So as I mentioned, the chain network was a very huge observational study. So the data exceedingly grew large. So this slowed down the app. The loading time was a bit, it was loading a bit slowly, and this basically annoyed a few people, or rather the users. But unfortunately enough, we got a remedy for that. And I'm happy to say that the speed of the apps were up again. But I'm just letting anyone know that who is planning to implement this, that when your dataset grow larger, you'll have the problem of a slow app. We had like infrastructural challenges, whereby sometimes the servers were down, so we used the servers for the organization, so making the apps basically inaccessible sometimes. So, but this one basically we only relied on our IT team to save us on this. The other challenge was processing data from different sources. So I said we use REDCap to store clinical data, and we used the relational database management system to store lab data. So these were two different data repositories. So getting data from those two different sources and processing them within the app was not like an easy task. So again, I would say we later on, in the spirit of the previous slide, we later on thought of a developing idea that helped us basically overcome this challenge in our dashboard and in our applications. So the Rshiny dashboard does not really stop on data management, automating data management. You can basically use it on other areas as well. So for the people interested in spatial data analysis, I find Rshiny dashboard quite useful because of the interactive nature of actually doing the spatial analysis and the visualization. And also, I think it can also be used to create data products for various statistical analysis and modeling. And one of the advantages of the Rshiny application is that you don't really have to have the knowledge of R to basically use them. So once everything has been written, the code has been well written, it's running as intended. You don't have to have the knowledge of R or RStud or Rshiny to use those applications. You can use them as any other web page and basically get whatever output you actually desired. Yeah, and I think we can also use the Rshiny dashboard for highly engineered data cleaning and anomaly detection tools. So currently we are working on creating an app that will assist in cleaning growth data, like data that has been collected over time. But that one will be basically for young infants. Yeah, so I think that's one area that the Rshiny application can be thoroughly used, such that now once this data product is up and running, you just have your data set, which you want to do maybe cleaning for, upload on the app, then basically get reports in terms of the health checks that have been put in place for that particular purpose. So with that, I think marks the end of my presentation, and I would like to acknowledge a few partners who made this particular study possible. Thank you, Marcy. Back to you.
Thanks, Christopher. Thanks for the talk, for the time that you invested in the preparations, and for being here. I know it's late, your time in your time zone, but let's have you for next 20 minutes. There's a couple of questions on the chat. So maybe let's start from the top. So you were talking about a clinical study. The question was whether the data is available as an open source object, or this is just strict to the trial and only available at your project.
Okay, so I'll say that this is not available as an open source. So this was a real a research study that was funded by this institution, and it's ongoing. We are basically in analysis stage, so no, it's not available as an open source, but the code can be available as open source, but the data set itself cannot. It's not available as open source.
Mm-hmm. And when the trial ends, when the project will be done, is there any chance that data will be available? How does that look?
So, well, within the KEMRI-Wellcome Trust Research Programme, so we have the data sharing committee, and I think once the research study ends and the paper has been published, so we share with that committee, which is in charge of now external requests, who will want to use that data. So the short answer is yes, but it probably will go through various channels and various approval for you to get it.
That makes sense. Yeah, that's typical for research clinical trials, that it takes some time until they are published, but yeah, looking forward. So maybe I will combine next few questions. So are there any alternatives for the REDCap? And that's another question, is REDCap just specific to clinical trials, or can be used in other surveys?
Okay, so I might have missed the first question, but let me go with the second one. So yeah, REDCap can be used for other surveys. In fact, it has this mobile app, Android mobile app, which you can use to remotely collect data and send, like they say, the same way if you ever used ODK, the Open Data Kit. So that's the same way REDCap has implemented a mobile app which is Android based, and you can use it to do various surveys. So you can even use it to do even cross-sectional studies, basically any data that meets the definition of a research study. You can use it. You can use REDCap to do that.
Mm-hmm.
Yeah. And maybe if I got the first question correct, is whether REDCap is free to use or open source?
Other alternatives? Is there any other competitor?
Well, yeah, there is, but most of them are commercial. So there's one goes by the name Open Clinica. So they, of course, they have an open source. They have a community edition where you can just get the application then set up. You don't have to pay anything. But the more advanced one are commercial. We have one thing called Alea. Yes, those are all commercial. So when it comes to open source, I think REDCap stands up in some way. But again, to clarify, it's not REDCap is not like open source per se. It is free to use, so you cannot go as an individual and be given REDCap instance. So it's an institution and profit institution that will be given that particular license to use REDCap, and it's free to use. So it's not like an application you'll go in Android store and download and install. No, it's open source, but it's free to use, but not open source as such.
Okay, that's good to know that it's free to use, and the data collection is also free. Like every response is not paid.
Pardon?
So this is free to use. You don't pay for the data collection.
No. No. It's free to use. It's free to use.
Okay.
So it's just that you need to have the manpower, rather the resources to be able to develop your tools. So they don't do it for you. So you get just a blank instance, everything within. So you need to get people with the right skills to be able to build your database from the particular system.
Okay, I see. I've seen similar platforms that are also free, like Qualtrics, but they charge you for responses. So every response is charged like $1 or $0.50, depending on your plans. So this looks like REDCap would be a better suit.
Yeah.
Alrighty, there are many more. So so you mentioned that there's an R package, REDCap API. Would you recommend using that package or maybe calling the API directly? I know that R packages often provides a limited amount of endpoints, and using the API directly gives you more features. So in this case, is it better to use R package or calling the API directly?
Well, I think I'll say this will depend in what works for you really. And for us, I think we saw it. We maybe due to due to the timelines that we were working with, so we saw it better to just basically use the R package itself and not try to go the other way around. So yeah, but I will say it will work, but it depends on really what you prefer. It's preference based.
All right, I see.
Yeah. So the only endpoint, the main goal is you get your data into your system as you want it. Then how you, whether you use the API call or whether you use the R package itself, I think that's a point of preference. What do you prefer? Yeah.
Okay, let's move on. A couple of questions regarding Rshiny. So there's one. Did you use the Rshiny server hosted somewhere at your project, or did you use Rshiny Apps? And is there any use case for using Rshiny Apps, that's a website, in your work?
Well, so we didn't use Rshiny Apps website, or we didn't use that Rshiny. So I know. So you are referring to shinyapps.io, where you can host your applications. So that for this case, that was risky because that's a third-party platform, and we were working with research data. So the ethical issues around it, you don't want to give somebody your research data. Yeah, so we set our own instances in our own servers.
Totally makes sense. Okay,
Yeah,
yeah,
so
yeah, yeah.
yeah.
That's a game changer when you have some data that you cannot share. Makes sense. And then there's a question from Leaky. Did you need to use advanced Shiny technologies like modularization, or did you need to use R6 classes? How advanced is this Shiny app? It looks pretty advanced in my opinion. You had an option to log out. You had multiple dashboards. Every of them used data table and some kind of plots. Yeah, how advanced was the Shiny? Tell us more.
So I would say not that. In a scale of 1 to 10, I would say it's about 6 there. And the only thing we had to do in terms of optimizing the application is stop doing things on the server side script. So we just decided to use there's an extra script you can use called global.r, whereby now you run all the process that will eat up time in terms of data, reading data, processing, creating variables. So you do them from within global.r, because that's a script that runs once in a session, so that if it's a data processing task, you don't need to do it each time a user clicks something on your on your dashboard. So we've thought of modularization, but I think we didn't reach a point whereby we were able to implement it. But I think that was our next opportunity to take. So yeah. So for Leaky, I think those two we never went that advanced with this particular application.
Okay, okay. I see. I understand. There are two more, and you are free to go, Christopher. I know it's late, your time. So Brian is curious about the cost of the process. What are the cost implications of the whole automation process? So I can imagine probably the Shiny server, our server machines, maybe some other stuff. How how costly is the workflow? Or maybe there are no costs for you.
Yeah. So for me, because the IT infrastructure basically was already set, so I would say there were absolutely no costs. We just kicked in the skills and developed the whole thing from scratch. And because when it came to now hosting, setting up their studio server, the Shiny server, the organization server already there, we were given an instance in the organization servers. Then we set our own Shiny and our studio server there. So, but I think if you want to, as a person wanting to start from scratch, you really need a lot of IT background to be able to hack that out. So
Mhm.
it basically depends on the scale
Okay.
on which you want to implement that. But yes,
Yeah.
there will be some costs if you want to set this thing from scratch.
So for the environment, you would need to have a machine that stands for the server, for the Shiny,
Yeah,
and for our studio.
yeah,
And also there is a like skill set that can't be priced that you need to have.
yes.
I see. Alrighty. There's a note from Andrew. He's asking whether you have used REDCap validation for data entry checks. Is that anything that you could use in your use case? REDCap
Sorry, I lost.
validation.
Sorry, I lost you. I lost you. Lost you. Sorry. Can you come up again?
Okay, maybe I'll repeat. So Andrew had a question. Uh, why don't you use REDCap validation for data entry checks? Is it a use case in your case?
Okay, that's a very good question, and it's an issue with basically most databases. So one thing I'll say is that yes, there are validation checks from within all databases, but for REDCap, validation checks are not really. They are not. They are not hard validation. So what do I mean by hard validation? Uh, for example, if you put a range of say temperature, so maybe temperature should not exceed some X value. If you put a value that exceeds that X value of your range, it will give you a warning, but it will not stop you from proceeding. That's not like other databases, which will basically stop you from proceeding, telling you that this value exceeds what is required, what is acceptable. Yeah. So with that, I think I will say a downfall on maybe a shortcoming on REDCap, and even the database which have hard validation, you'll want to customize your own cleaning process outside the database. So the validation checks, I will say that's maybe the first line of defense, whereby now for person entering data who is keen can be able to see those notifications and basically try to correct whatever they are doing from within. But I will tell you, it doesn't matter how advanced or how efficient those validations are. You will want to do an external customized check on your data all the time.
Okay.
Yeah.
Okay. I see. Good stuff. Good stuff, Christopher. I think we can call it a day. I'm gonna stop your screen sharing and we'll present mine. So thank you for joining, Christopher, today. It was a pleasure to have you here. We had like more than 50 people attending and Epic at 60. So that looks very popular. And I hope other folks will have a chance to see the recording in their free time. So there's always a chance to get back to the YouTube URL. The recording will stay at the very same address. And I would like to express my gratitude to our sponsors, Jumping Rivers, who are kind enough to support our foundation, thanks to which we are able to organize those meetings. And Jumping Rivers is an analytical company whose passion is data and machine learning. And on their website, you can see that they offer a lot of R courses related to usage of R, but also related to statistics or even Python. So if you ever need any help or would like to get a professional training, and then there's one recent one about Bayesian interface that you can also attend. So there's their website, and we are happy to get their support. And yeah, I think that's all for today. Christopher, if you have any last famous words, here's your last few minutes, and yeah, then let's call today. And I think you're muted, Christopher. Sorry.
I just want to thank everyone who got time to listen to this presentation, and I just encourage the creators of automation. I think Rshiny is it's very simple to implement, and it comes in hand in solving most of the problems that you will want to do, which are repetitive. So that includes analysis, not only data management, and yeah, and life will be very easy. Thank you.
Thanks, Christopher. Alrighty, let's call it a day. See you all next week, the very same time, the very same day, and we will have Susan Holmes with data analysis related to microbiome data. So thanks for joining and have a great evening and see you next week.